day to our lecturer, Dr. Setia. Today, I and my group mates, we will present about the fluid mechanics assignment, pressure in pipe. Before that, I will introduce myself. My name is Seelan, son of M. Gunasekharan. My matrix number is B09211047.
Hello, my name is Muhammad Afzal Zulhazim bin Zulkifli, and my matrix number is B09211040.
Hi, my name is Nur Izzati Shafika binti Muhammad Tarmizi. My matrix number is B0921100025.
I am Tariq Muhammad bin Gula Muhammad. My matrix number is B0921105334.
Hi, my name is Muhammad Amirul bin Abi Rahman. My matrix number is B0921105500.
Next, for the content slide, Amirul will take over from me.
Okay, so for the content, the first one we have the introduction, we have the objective, we have the list of equipments, we have the working process of the experiment, and also we have the simulation. And other than that, we also have the video experiment attached, the results and the calculation, and finally the conclusion for our assignment. Okay, next. So for the introduction, this assignment is about the experiment regarding two types of pipes configuration, which is the straight line and the closed loop. In order to analyze the pressure variation in hose pipe with two configuration, an investigation is carried out by conducting the experimental and also the simulation flow exercise in the hose pipe. Okay, the third one is to identify whether it obeyed the Bernoulli's principle or not. So this experiment is carried out. Okay, the first task is done to justify the maximum flow rate, the velocity, the maximum achievable jet, and the maximum pressure in the pipe. So the second task is to requires to install ANSYS and generate the type of hose pipe configuration. Okay, so next is the objective. So the objective of this assignment is to perform experimental and also the simulation flow exercise in hose pipe. The second one is to analyze the pressure variation in the hose pipe of a specific pipe length with two different configurations. And the third one is to report the findings in an appropriate approach. Okay, next one. Okay, next is the list of equipments that we use in this experiment. So the first one is the diameter single connector. The second one is the 60mm T connector and 60mm times 10m hose pipe. Other than that, also we use the stopwatch for the time recording. Also we use hose clip and 5 or 10mm measurement cup and 10-liter measurement tank. Okay, next. Okay, so this is our working process of the experiment for the straight line. So the first one, all the equipments that will be used is prepared for this experiment. So 16mm times 5m hose pipe is cut using the scissor into 2m to make the straight line water hose as shown in the experiment sheet. So the third step is we make holes, 5 holes that is made on the hose. So the distance of the hole to hole is measured by using the ruler, and also making the holes by using the electric soldering. And then the end of the pipe is blocked. Also, the tap is opened up. The tap is opened up to maximum, and the flow rate or the velocity is measured at each hole at all in once over the same period. And the last one is all the data is recorded by our group member. Okay, next. So for the working process of the experiment, closed loop, the steps are the same but different in the term of its design. So the first step, by using the remaining hose, 60mm times 5 holes is cut to 1.20m by using the remaining hose. The second step, the Y connector, 60mm Y connector is used to make it the closed loop. Okay, so the 10 holes for this closed loop, we make 10 holes. We make 10 holes that is made on the hose. So the fourth step, the whole pipe is ensured on the same level. So the tap is open at maximum and the flow rate or the velocity is measured at each hole all in once over the same period. And the last step is all the data is recorded by our group members, and all the data is recorded recorded properly to avoid any errors. Okay. So next, I pass to my teammates.
So this is the simulation result that we have done using SolidWorks. For the straight line simulation, the inlet velocity volume rate average value is 0.0095 meter cube per second. The minimum and maximum have the same number, that is 0.0095 meter cube per second. And the average value for static pressure is 2684339.41 Pascal. The minimum value is 2669639.993 Pascal, and the maximum value is 2690702.36 Pascal. Next slide, please. This is the simulation of straight line. As you can see right here, the overall picture for the straight line simulation. Next. And this is the flow simulation on outlet 1 to 5 for straight line. Next. This is the goal plot for closed loop simulation. The velocity volume flow rate is 0.0101 meter cube per second. The static pressure average value is 5585974.28 Pascal, and the minimum value is 5562908.17 Pascal, and the maximum value is 5614817.47 Pascal. Next. This is the overall picture for the closed loop simulation, and this is the flow simulation on outlet 1 to 10 for closed loop. That's it.
Okay, this is our video experiment. This first video is for straight line water hose configuration. Let me play it. In this experiment, me, Izati, holding the stopwatch, and Silen taking the 200 milliliter of water. And for this one is closed loop water hose configuration. Next,
Okay.
okay.
Okay, next is about the result of the water jet, the closed loop, and also the straight line pipe. Next. For the task one, is about the water jet, which is the maximum water jet meter is 0.04, and the pressure one, maximum pressure in pipe is 101,717.4. Next. Okay, next is next is about the water jet, how we get the pressure 101,717.4 by using the Bernoulli equation, considering the system is frictional and Z1 is 0 because it was at the reference level, which is ground. Next is V1 is negligible, V2 are equal to 0 because it was the top of water trajectory. And next is pressure 2 is the atmospheric pressure, which is 101,325 Pascal. By substituting from the Bernoulli equation, we get pressure 1 is equal to pressure 2 plus Z2 rho G, where pressure 1 is equal to 101,325, which is pressure 2, plus Z2 is 0.04 times with rho is water times with the gravity, which is 9.81. From that, P1 we get 101717.4 Pascal. Next. Okay, how we calculate the velocity? By using the formula which is V is equal to 4 times with Q. Q is the mass flow rate divided by pi diameter square, where Q is the flow rate and D is the diameter of the water hose. Next. Next, about the straight line pipe, where the diameter of connector hole is 3 mm. The total length of the system is 2.58 meter. The measuring cup is 250 ml. And height of water is 0.90. The number of connector that we use for the straight line is 5. And for the each of the connector, the time taken is different. And the distance of the connector main supply is also different. Next. Okay, next is the closed loop, where the diameter of connector hole is the same, 3 mm, but the total length of the system of closed loop is 6.4 meter, and the measuring cup that we use is 250 ml, the same as the straight line, and the height of water of the closed loop is 0.6 meter. Number of connector that we use for the closed loop is 10, and each of the time taken is different. The distance of the connector for each 1, 2, 3 till 10 is different. That's all from me. Next, Afzal.
This is final part of our presentation, which is conclusion. The first point is we were able to carry out this experiment flow in hose pipe successfully. Second, we observed that when fluid moves at high pressure to lower pressure, the velocity will increase. And from the observation from the calculated value, flow rate, water jet, and pressure in closed loop hose are much lower than the straight line hose. Next, we can conclude that the Bernoulli equation is valid for flow as it obeys the equation. And the last one is, in this experiment, we can summarize that the pressure are directly proportional to the velocity. So when the pressure increase, the velocity increase. That's all from us. Thank you.